Okay, ladies and gentlemen, yesterday when we left off, we talked about systems of linear equations in three variables, yes? We remember doing all this, and I told you at the end of the class that we get lazy when we're doing all these, when we're drawing these equations, because we got to do it. How many times did we do this system of equations?
5 times.
How many times did we rewrite it? We wrote it once, and then we rewrote it 1, 2, 3, and then 4, 5 over here, right? All to get an answer of, I think it was x equals 1, y equals -1, and z equals 2. Okay? And we said, well, there's a way to truncate this, or a mathematical shorthand, so to speak. And I gave you something that looked like this. What did we call this? A matrix. Do you want to know what it is?
No, but yes.
Take the red pill. And, all right. Who's seen that movie?
Matrix?
One person, two people. Let's see. 4.
Well, we should watch it, class.
You should watch
So
it.
we understand.
Big class.
You should watch it. That is one of the great.
What's on Thursday?
I love.
Wednesday, Thursday.
Yeah.
I think it's on Netflix. I got a Netflix account.
I say today.
We're going to do this, my friend. We're going to do this. But how does this, let's look at the top row here on this matrix. How does that correlate with this system of linear equations?
The coefficients for all the variables.
It's the coefficients right here. 1 is the coefficient of my x variable. -2 is the coefficient of my y variable. 3 is the coefficient of my z variable. And 9 correlates to that 9. Okay? So this is just a way for me not to do as much writing and to get muscle cramps from writing so much. Does that make sense? Now I'll prove to you that when I do it using this, I get the same thing as I do when I use this. So that's what we're going to do today. Okay? Now, a lot of this is going to look identical, but there's going to be one twist at the end, and I'll show you that at the end. But let's get started on that, okay? Where's my glasses? I don't want to squint while I'm looking at y'all. So, I started a second page, and this is the same system of linear equations, except it's written in matrix form, okay? And these are the answers that we got yesterday, okay? And we're going to do the exact same thing that we did yesterday, okay? We are going to add, subtract, combine rows of values so that I can find the answers to my variables, okay? So let's get started, right? First of all, I got this. Do I have to write this big, first of all? I would like to make it smaller. Maybe like, oops. Maybe like row 1, row 2, row 3, and go. Are we cool with that? All right. What is the most obvious thing that I can... So remember, when I did it with the equations, I wanted to get rid of the x's here, and I wanted to get rid of the x's and y's here. So that was just had y's and z's and z's. So what would be the first step? Let's try and get rid of this x, shall we? How can I do that? By adding an equation to it.
Add row 1 and row 2.
Yeah, so I'm going to keep my row 1, right? I'm going to keep my row 1. That's 1, -2, 3, and 9. Okay? But I'm going to make a new row 2. Is that okay there, Dawson? Okay. I'm going to make a new row 2 by adding rows 1 and 2 together. And that's going to give me my new row 2. So when I add row 1 to row 2, in the x column, 1 plus negative 1 is 0, right? So what do I put here? I put a 0 there. That's the coefficient of my x variable, right? Negative 2 plus 3, 1. 3 plus 1, 4. And 9 plus negative 2 is 7. And now I'm just going to write 3 down. 2, negative 5, 5, and 17. Now I'm going to make another row 1, row 2, and row 3. Now, how do I get rid of this x right here?
2 times R1.
Yeah. So instead of subtracting, I'm going to multiply R1 by negative 2 and then add it. Same difference, right? It keeps it straight in my head. I have a better time of keeping it straight when I do it that way than doing it the other way. Okay? Is everybody? You don't have to agree, but do you understand where I'm coming from? Okay. So I take row 1. Negative 2 times 1 is negative 2. Plus 2 gets me playing with row 3 now, right? Should I just write row 1 and row 2 out? 0, 1, 4, 7. Okay, now I'm working row 3. So, what did we all get for the first entry of row 3? You get 0, right? How about the second entry of row 3? Remember, I'm doing negative 2 times row 1 and adding it to row 3. Negative 1. Good. And then for the third entry in row 3, negative 1. And then somebody other than Henry or Alex, what's my last entry in row 3?
Good guess.
It's not a guess. He's on point. Negative 2 times 9 is
What?
plus 17. Negative 1. It's not a guess. It's not a guess.
I just thought it was a coincidence that those won't be ones.
Okay. Now, can I do this? Can I do that?
How about negative?
Yeah, I'm multiplying both sides of that equation by negative 1, right? Except that's department redundancy department. I don't need those pluses in there. The heck with those pluses. Now, I got to get rid of this guy, right? I want to keep this 1 over here, but I want to get rid of that guy, right? So how do I do that? Yeah, subtract row 2, right? Or add the opposite of row 2. So let's do that. So I'm going to make my new matrix. I'm going to row 1, row 2, row 3. And I'm going to keep row 1 the same. It's 1, negative 2, 3, 9, 0, 1, 4, 7. Now, I'm figuring out my new row 3. I'm taking negative 1 times row 2 and adding it to row 3. So what's my first entry in row 3, Dawson? What do I put here? 0. Negative 1 times 0 plus 0 is 0. What about my second entry, Abby? What do I get for my second entry? Yes, that's what I wanted to get too, isn't it? That was the whole point of this, is to make this that. So good. What about my third entry? What do you think, Noah? Remember what I'm doing? I'm taking -1 times this row and adding it to this row. So I've done it for this entry, I've done it for this entry, now I'm doing it for this entry. -3, -3. -1 times 4 is -4. Add that to 1, I get -3. Now, I got to do the same thing to the last entry. -1 times 7 is -7. Plus 1 is -6. Okay, so now this last row, I'm going to get rid of these underlines here because we don't need them. But what does this last row, what equation does that represent?
-3x equals -6.
Not x,
Or y. Z.
z, right? Remember, this is your x, this is your y, this is your z. So -3z equals -6. Can I simplify that equation? Zach? -3z.
Well, yeah, but -1 equals -2. Call it.
Remember, the equation this represents right here is 0x plus 0y minus 3z equals -6. Can I simplify?
Oh, yeah.
Can I simplify?
It's -2.
Z equals -2. What would that look like?
Positive.
Positive, right? Negative divided by negative.
Absolutely.
Can I change this to a 1 and this to a 2? That's what I'm going to do. I basically divided both sides by -3, right?
Yep.
Okay. We did this yesterday. We did exactly this yesterday, except we're doing it in a different format, okay? That this is the exact same thing with the exact same problem that we did yesterday. Now I'm going to change it up a little bit. I'm going to change it up just a little bit. Yes, but no. Okay? Now, here's what I want to do. I want to make this guy 0. How do I do that? I want to add another equation to this to make it 0. So R1, R2, R3.
-4 R3. 4 R3 minus 2. Or minus R2.
We could do that, but if I do that, I'm going to have a -1 here, right? So if I'm subtracting R2, that means this is minus, that's minus, right? So let's do R2 minus 4 times R3. Or better, yeah, let's do R2 plus a -4 times R3. Feel me? So, what do I get when I multiply -4 times 0 and add it to 0?
0.
We can do that. We can do that math, right? Now, what happens when I multiply -4 times 0 and add it to 1? I get 1. What happens when I multiply -4 times 1 and add it to 4?
0.
0. What happens when I get -4 times 2 and add it to 7? -1. What? So this bottom equation right here, or this bottom row, what equation does that represent? Z equals 2. Z equals 2. What about this middle line? What does that represent?
Y equals -1.
Y equals -1. I want to show you something. It's go back to the top of the page.
Whoa.
Z equals 2, y equals -1.
Who would have thought?
Who would have thought? So now, my next step is going to be, let's finish this row, 1, -2, 3, and 9. My next goal is to make these guys zeros. Using the same step that I just used to get this guy into 0. You feel me? So let's do that. Do you want to do it in 1 step or 2 steps?
2.
Dawson says 2. He sounded pretty dang adamant about that too. All right, so let's do that. I'm going to extend the page so I got some room. And I'm going to do row 1, row 2, row 3. Now, what number do I want to get rid of first? Do I want to get rid of the -2 or the +3? Dawson's running this show. You want to get rid of the -2, Dawson? How do you do that?
Add
2 times row 2 and add it to row 1. I like that idea. So I take 2 times the 0 in row 2, which is 0, add it to row 1. What do I get there? I get 1. 2 times the 1 in row 2.
2.
I get, and add it to -2. I get 0. 2 times the 0 in row 2. Add to 3. 2 times the -1 in row 2. Add it to 9. 7. I'm just doing adding, subtracting, multiplying, and did a little dividing here, right? That's all I'm doing, right? This is 3rd grade math. It's just that we're employing some organizational skills to keep track of everything that we're doing, right? All we're doing is inventing an accounting system right now. Okay? So let's keep these. Now what do I want to do? I want to get rid of the 3. How do I do that? Go ahead, Zach. And then what? Okay, let me finish out row 2. Because I'm not playing with those anymore, right? So now, Zach said, I'm going to take row 3, multiply it by -3, and then add it to row 1. So, when I do this column and this column, does that change row 1 at all? No, so I'm going to just write that 1 and 0 down. But this is going to change, isn't it? What is -3 times 1 added to row 3? 0. And then -3 times 2 added to 7. So what's this row say? X equals 1, 2nd row. And 3rd row, Z equals 2. That's all this is. Don't get intimidated by the question you couldn't answer on the ACT. This is just an accounting system. So all it is an accounting system. Okay? Now, does this seem like more or less work? It seems like more work, right? Doesn't it? Let me ask you this, though. What is that? It's a spreadsheet, right? Now, if I put this let's do 1, -2, 3, and I think this was 9. And then I got, what was my second entry?
-1,
-1, 3, 1, -2. -1, 3, -3, right?
Oh, true.
just 3.
Just 3?
That's a 1.
And 1, and -2. And then I had
-5.
1,
No, it's 2.
-5, and 5.
It's 2 at the front.
All right, and what's this though?
17, that's 2 at the front.
17.
And this was a 2, you say?
Yes.
When I do it this way on a spreadsheet, and then I can do formulas in here to make sense of them, I can use computers to help me. Now, if I learn how to do this, does that make my life easier?
Yeah.
It does. It does. If I learn how to use the tool that is either Microsoft Excel or Google Sheets, right? So this is what we're going towards, okay? And I'm going to give you a little taste of something on Friday, I think. Maybe on Tuesday. But I want to use this process in a new context. So we're going to do a sample problem together. It's a word problem. It's on page 508 in your book, I think. Yes, 508. We're doing problem 100 on page 508. So I know a few of y'all like basketball. The rest of you, I just need you to do the math, because I know you love math. What was that, Jim? What was that?
Sorry, we'll be
508. And it says, in the 2005 NCAA Men's Championship Basketball game, the University of North Carolina, can you see how old this book is?
Yeah.
It's an old book, isn't it? University of North Carolina defeated the University of Illinois by a score of 75-70. North Carolina won by scoring a combination of, this is for all the non-basketball people in the crowd, a combination of 2-point field goals, 3-point field goals, and 1-point free throws. The number of free throws was 3 more than the number of 3-point field goals and 6 less than the number of 2-point field goals. Find the combination of scores that won the national championship for North Carolina. So, in a nutshell, I got a word problem here, right? My first job, whenever I got a word problem, to find my variables. What don't I know?
number of 3s, 2s, 1s.
Number of 3-point shots, number of 2-point shots, number of 1-point shots, aka free throws. So what do I want to assign as variables for those 3 values? Dawson says X, Y, Z. I think it's a heck of an idea. X, Y, and Z. What do we want X to equal?
3s.
3s. What about 3s?
Number of 3s.
Number of 3s that I attempted?
Made.
Number of 3s made. So how many T-shirts they threw out at the game, right?
Usually they throw out 3 t-shirts per 3-pointer.
Oh, do they?
Yeah.
Wow.
That's the way I did it when I had the t-shirts we used when I was younger.
Is that why the SBA's broke?
Probably.
Teasing.
Because they let people throw out
Okay, so what do we want to make Y?
2-pointers. Number of 2-pointers.
2-pointers, you agree with that, Alex? Do you care? And then what is Z going to equal then, Zach? Yeah, number of 1s or number of free throws. Okay, So that's my first.
Ask more questions.
Sir. All right. See, I picked this question for you. I figured you like basketball.
Here's the feel weak.
So-
before you said the question.
Can I glean an equation from the word problem? Now I've defined my variables. I want to set up equations, right? I want to set up equations. What would a good equation... Here, I know which one I want to start with. I want to start with the hardest one. Finish it. What's the significance of the number 75? That's their score, right? How'd they get 75? Why 3x? Why not 2x? Yeah. So, Alex is saying, well, if I made x number of 3-pointers, the number of points I get from those 3-pointers is going to be 3 times whatever I made, right? So 3x plus 2y, somebody other than Henry or Alex,
Plus 1z.
plus 1z. I'm just going to say plus z equals 75. Now, what is I want that to be blue. All right, let's do a second equation. What is the second equation that I can glean from this?
Y plus z equals 75 minus 3x.
You're just rearranging the same equation, right?
Yep.
I need a new relationship.
3z plus 2x plus y.
The number of free throws was 3 more than the number of 3-point field goals.
The 3x, no.
The number of free throws, which is what?
3x squared.
Z, the number of free throws is 3 more than the number of 3-pointers.
TP.
Is that an accurate equation? Is that how we like seeing our equations? What's the matter with that equation, Dawson? Well, how have I been writing my equations up until this one? What's the difference between those?
All the variables on the left.
Yes, all the variables on the left, and then a scalar number on the right, right?
Z minus x equals 3.
Yeah, or I want to actually keep it in standard order, right?
Negative x plus z.
Negative x, and I want to keep track of that y, right?
0y.
Plus z
Oh,
equals 3.
thank you.
That's going to be my second equation. No, I don't want that. I want that. Nope, you can't do that. I gotta do it this way. All right, so I'm going to write that in blue. Negative x plus 0y plus z equals 3. And then, what's my last equation going to be? So, Alex is saying z equals y minus 6. What is the sentence that you got that from, Alex? Yep. So,
6 less than the number of 20.
so the number of free throws is 6 less than the number of 3-point field goals. Or no, 2-point field goals. I'm sorry. 2-pointers, right? Why not 6 minus y?
But the number of buckets.
What if you only got 2 3-pointers?
Well, I don't think that's
But
true.
what?
You said you're going to get a negative number for number of 3-point buckets or 2-point buckets.
You can't have you can't shoot a negative amount of.
But it's written, it says that the number of free throws is 6 less than the number of 2-point free throws or field goals. And so it's written 6 less than the number of 2-point field goals. Right? 6. The number of free throws is 6 less than the number of 2-point field goals.
It's 6 minus number.
Yeah, why can't I do this?
Because you're taking y away from 6, not 6 away from 1.
Oh, okay. So, you're going to see a lot of cases where they write it that way, and then you're going to jump to this conclusion, and then I'm going to do jazz hands, right? Okay? So this is y minus 6 is the right expression, but is it written in the way that we can use it?
No. On
I want
0x minus y plus b equals negative 6.
minus y plus z equals negative 6.
Miriam?
Okay, so that's what I'm writing over here. 0x minus y plus z equals negative 6.
Matricize it.
We're going to matrix that thing. So we do 3, 2, 1, 75. Negative 1, 0, 1, 3, 0, negative 1, 1, negative 6. And then we do the same thing that we did before. Okay? So, good news here. I got a 0 there and I got a 0 there. Is that going to make my life easier?
Very much so.
Yeah, let's do this then. What do I want to get rid of first?
Negative 1 for x.
You want to get which one?
Middle x.
Bottom one.
That's tough.
Negative, I said a negative 1 for x.
Kristen, your tiebreaker. Which one do you want to get rid of? Or do you want to get rid of something entirely different? You want to get rid of this one? Okay, how do I get rid of that one? How do I get rid of that one?
You multiply R1 by 1/3.
3. And then you add them together.
Yeah, so 3 times, so let's label these again. Row 1, row 2, row 3. Let's multiply row 2 by 3, and then add it to row 1. And that's going to give me a new row 2, right? So, row 1 stays the same, right? 3, 2, 1, 75. But I want to multiply row 2 by 3 and add it to row 1, which gets me 0. I want to multiply 3 times row 2, add to 1, I get 2. 3 times row 2, add it to 1, I get 4. 3 times row 2, add it to row 1, 84. 9 plus 75, right? Okay. And then I get 0, negative 1, 1, negative 6.
Let's just subtract row 1.
What do you mean subtract row 1?
Never mind.
Well, we just effectively did that though, right?
Yeah, probably.
R1 minus 2R3. Or sorry, plus 2R3. That would give us 2R3.
So let me ask you this. Does it matter in which order I do these things?
No.
No.
It really doesn't. The goal is to make that a 1, that a 1, and that a 1, and have the rest of them zeros, right? That's the goal. But there are 3 things that you're allowed to do. You are not allowed to do anything other than these 3 things. Those things are: 1, you can add any equation i.e. row to another equation i.e. row. So I can take row 1 plus row 2, or row 2 plus row 3, or row 1 plus row 3, and I can add them together to give me a new equation. Right? That's one thing that I can do. And we've seen ourselves do that plenty of times, right? Second thing I can do. 2, you can multiply any row or equation by a non-zero scalar. What do I mean by a scalar?
Number.
Just a number, right? The only thing that I need to be sure of is that it is not 0. I can do a positive number, yes? I can do a negative number, yes? Can I do a fraction, Abby? Have I done a fraction thus far? I haven't? What did I do? Remember, right here. This wasn't 1 and 12, was it? I think it was 3 and 36. Or was it 2 and 24? What did I do?
There was a -3, -6 divided by -3. Or multiplied by 1.
Was that down here? No, that's, sorry, this one. This one right here. That wasn't 1 and 2 originally, right? That was 3 and, or no, -3, -6, right? What did I do? Doesn't say I can divide though, does it? I can multiply by a non-zero scalar. So when I say divided by -3, what did I multiply by? -1/3, right? It's non-zero, it's a scalar, right? Okay? So that's the second thing I can do. The third thing I can do, you can change row / equation locations. Okay. So, if I want row 3, or I'm sorry, if I want row 1 down on the bottom for row 3, for whatever reason, can I do that? I'm really just changing the order in which I'm writing these equations, right? I don't need to be... Think about this. If I decide to write this equation first, and then this equation, and then this equation, does that change what I'm doing?
No.
No. It just changes the order in which I wrote it in, which really doesn't matter. Okay? So these are the 3 things that I can do. Those are all the 3 things that I can do. Okay? Does it say I can divide? It doesn't say I can divide, but but divide, not explicitly, right? Not explicitly, but it implies that I can, right? It implies that I can by multiplying by the reciprocal. So long as it is not zero. Good.
-0.
Let's throw this at you. All right, so let's continue this. Let's continue this. What do I want to do? So notice, I wanted to get rid of this -1, right? And I did that. Oh, goody. But what did I do to this thing? Yeah, I had 0 y's here, and now I got 2 of them. So what do I have to do to that? Let's get rid of it. Do I want to get rid of the 2? Or do I want to get rid of this -1 down here? -1? How do I do that?
Go 3 by 2 and subtract.
By R1.
Add them, right?
Yep.
Row 1 or row 2? Why row 2? Why not row 1? Because look at row 1's got a 2 there as well.
Yeah.
Why not row 1?
Because then you get X.
Yeah, I get an X value. I don't want an X value, do I, Hallie? No, I don't want an X value. So let's do that. I'm going to write this down again. It's 32175. 32175. 02484. And then I'm multiplying row 3 by 2 and adding row 2. So my first entry is what? Second entry is going to be 0. Third entry, so remember, row 3 times -2, or row 3 times 2, add 4, that's 6. -6 times 2, add 84, 72. There is my new system. Now what can I do? Row 1, row 2, row 3. Divide both sides by 6. Or if I want to stay true to the language of my 3 rules, I want to multiply both sides by 1/6, right? Either divide by 6 or multiply by 1/6. All right, so when I do that, what do I get here? 72 divided by 6. Yeah. Oops. 1. So, what does this bottom line mean in context of my word problem?
12 free throws.
Bam. Made 12 free throws. Okay. Now, I want to make that a 0, yes?
No.
How many 2-pointers?
Yes.
I want to make that 0. So, row 3 times -4 plus row 2. That's what I'm doing. Three, 2, 1, 75. Now, 3 times or -4 times row 3 plus row 2. What's the middle entry in row 2? Or the second entry in row 2, sorry. 2, right? It doesn't change because I'm adding 0. -4 times 1 plus 4. What's that going to be? -4 times 12 plus 84. 48. So 8, that would be 76 plus 70, 36, right?
Yep. Divided by 2.
Yeah, let's do that. What's that become? Yeah.
Oh,
I mean,
Now what?
Please.
I'm going to do it to the top now, right? I'm going to get rid of that. Probably going to get rid of that first because it's easiest, right? And I'm going to get rid of that next. Or can I do both of those in one step?
Whoa.
Let's do both of them in one step. Let's be ambitious. Let's be dangerous.
Add it into those 2 steps.
Well, I can really do this in one step. And here's why. Do I need to worry about anything with this one? That's just going to be 3, right? When I do this one, I'm just doing -2 times this plus this, right? So that's going to be 0, right? And for row 3, it was -1 times this plus that, so that's going to be 0, right? Let me put these 0, 1, 0, 18, and 0, 0, 1, 12. Now, here's going to be the tricky part. 2 plus, how many did I have to multiply this by? -2. So it's going to be -2 times this, right? Plus that. 27, or no, 36, 36, 39, yeah, 39.
Okay.
So 39, okay, but I also had to subtract 12, right? I had to subtract 12 because I had to account for this addition, right? 20, so 27 minus 27, and then, yes, now I'm multiplying by 1/3, and you get 1 and 9. One and 9.
They're all James Harden free throws.
Yeah, I knew it was 918. The whole way through. 9.
Okay. Now, you guys are probably soiling your drawers right now because this is a lot of writing and it's a lot of arithmetic, right? Here's always a strategy that works for me. When you start out with something that looks like this, the goal is always going to be to make these 3 things 0. The goal is to make these 3 things 0 first. That's going to be your first strategy. Second strategy, make this a 1 if it's not already a 1. Third strategy, make these 3 things 0. That's your third strategy. And your last strategy, make those 1s. Okay? If you organize your activities in that manner, it's a pretty easy process. It's just a lot of arithmetic and a lot of accounting of that arithmetic. Okay? That's it. Conflicts, gentlemen? Did I take a whole hour for that? Oh.